request anyone who is an architect, designer, or interested in tech to really keep your eyes and ears open. Something that we have put together for you, what happens in the design studio, as to what is our vision to enhance design efficiency using technology. When it comes to technology, what we thought is that it will be nice to focus on the idea of quality, which is the keystone of today's conference. And I think what we're about to show you is something fresh, something new that's happening in our minds when we think of ourselves as healthcare planner and healthcare architects. Quality is as important as it gets, as you've heard in most of these presentations which have been happening since today morning. So what we wanted to do is tell you that there are many ways to interpret what quality means, and because we are so varied in the professions that we come from, all of us will have different arguments for what quality is. So out of the multiple, probably infinite components of quality, we just wanted to focus on these 4 for today. Exploration is a good character of quality, and when we talk about exploration, we wanted to tell you that a good healthcare design facility starts with the exploration of multiple possibilities of how do you want to set back the building. So we talked about height restrictions, ground cover, and FAR. So a good healthcare approach towards architecture is to explore these multiple possibilities. The second one is about the consistency of quality, the consistency of anticipated movements in the hospital. Many times when you design hospitals, you also notice that they evolve over time, or sometimes you do something which doesn't work and the user group wants you to change something. So the consistency of anticipated movements in outpatient areas is something that we often work with, and we would like to show you how that kind of pans out in the design process. The second one is the accuracy of error-free distribution. So we have some people who with whom we work for facade designs. So when you get to facade modeling, dry cladding, double glazed units, it's very important to be precise in how do you develop these wall sections and elevations, because many times you must have noticed if you don't design a healthcare facility in the right manner, you will see ducts and wires sort of coming in, popping out from everywhere. So to get an error-free distribution of your facade design is very important, and we'll demonstrate how we do this at the studio. And also transparency of the design functionality. Many times it's not easy to read a plan. Even as an architect, I feel sometimes hospitals are so complex. I have to really open my eyes and read every line and annotation in the drawing. So we have developed some methods in design technology where we would demonstrate the transparency of the IPD floor functionality. So it's only with the presence of these qualities, exploration, consistency, accuracy, and transparency, that we can make healthcare design more efficient. So I will hand over to Ishan.
So we'll go over these one by one. So the first one is exploration in the possibilities of setback modeling. So typically when a project starts, you have your numbers, right? Like what is your plot size, what is your FSI that is allowed, what is the height restriction that is allowed, which should be increased or not, as we listen in the panel this time. And also what size of grid you are choosing. As ma'am said in the morning, what really dictates the building is the IPD floor itself. So this is the example. So the presentation is structured as to how we really work in the design studio, and how some digital technologies, which like we all know that BIM exists and it's really useful for documentation, but what are the other technologies besides BIM? What are the areas besides BIM that we need to innovate? So this is, for example, the red line that you see over here is the plot line, and given a setback of 6 meters from each side and a setback of 14.6 meters from the eastern side, what is the form of the building that you will see depending on the grid size that you have chosen, and what is the floor stack that you have, what is the maximum floor area, what is the plinth area that you have, what is the ground cover, what is the built-up area. So these numbers we all calculate whenever we are doing any sort of project, whether it be greenfield or brownfield. And there are also some analytical capabilities that we need to see of the form itself. So in this particular case, the building is a G+4 building, and you have a 35% north facade that you have obtained. Then your design mandate changes, because that's how design is. You always keep on encountering new challenges which come up as the norms evolve, as the conditions evolve. So now there is a need for accommodating for future expansion in your plot. So you take a massive setback of 40 meters from the east and you grow your building up top. Like we had in the discussions earlier, there is a certain height restriction to which clinical facilities are allowed. So in this case, beyond 30 meters, you cannot have any clinical facilities. So you will have either IPD or administration or any other functions that come above. So that is indicated in the yellow color. You again sit down and make your stack again, your plinth area, your GC calculation, your built-up area, you open your Excel and you update these again. Then suddenly the FSI of the project changes. Instead of 2.5, you now have a 5 FSI available. And maybe the promoter is now able to, have a phase-wise construction project. So maybe instead of doing a separate future expansion, you want to plan out how the building as a whole is going to come up. So the idea is that there can be an infinite amount of snapshots that can be created for any amount of decisions that have to be taken. And the real benefit would be is if all of these could happen at the click of a button. So these snapshots were actually taken from this video that you will see, which is an interactive CAD display, which allows you to manipulate your setbacks, which allows you to manipulate your FSI limits, and it grows and shrinks the building as per a dedicated grid amount that you have decided. So something like this, which usually takes a lot of amount of effort, and even more than effort, restricts you because you cannot make any building and then immediately have its areas at your disposal, or you cannot make these changes in a client meeting or in a workshop. So this was the exploration of the setback modeling that we wanted to share. Yeah.
Right. So the next quality of efficient design is consistency of anticipating movements within the OPD area. So in the design studio, we often work with different kinds of design options, right, as Ishan mentioned earlier. But when setbacks changes, when the brief changes, you're often provoked to think if the existing design that I did is good or not. So in this case, it's a bit different. We already had a design which was done by the client before, and we came in to evaluate the existing design and propose a new design. And I'll show you that even though these geometries look very different, I'll tell you what went behind these geometries to actually conclude the proposed design. So in the existing model, what we noticed that the left-hand side of the floor plate is the public entry and the right-hand side is the private entry. But we realized that after creating a distinction of the public and private, it was not really the case that even the movement was distinct. We noticed that the movement flow is mixing and clashing. So for instance, from the public main entrance, when you go across the floor plate, you have to do a walk of about 120 meters to go to the cornea OPD, which was giving treatment to both classes of the patient. That was also the case in the private MES, where the patients from the private entry had to travel about 100 meters in the opposite direction to go to the physician's OPD, which was having doctors taking mixed appointments. So this design would create a lot of clash right in the front of the hospital, where the corridor was also pretty thin. So you would have multiple clashes in the movement flow, which is not really a hallmark of an efficient healthcare design. So in order to solve that, what we did is that instead of taking common entries at a single face, we try to take entries at which are facing each other, and then have a streamline flow across a common corridor. So for instance, here you can see that the public entry is taking the same corridor which is taken by the private entry, but they kind of confluence in the middle and walk from facing directions. So this was the design for an eye hospital, and we also thought it interesting to develop the form as the shape of an eye, but streamline the interiors so that form should follow function, right? So as an architect, we believe that while form should be interesting, it should also be functional, wherein these kind of tools help you to take decisions. Another case was where people or patients, visitors from the main entrance services had to walk across clinical OPD areas to go to the cafeteria, which is also probably not the right thing to do, because again you would have clashes between people waiting or going between OPDs or taking the centralized core to go to the above floors, and having a big group of people carrying their tiffin or like bringing snacks from the cafeteria into the courtyard or the lobby. So public utilities were being reached by crossing clinical spaces. which also we try to avoid by ensuring that public utilities are not reached by crossing clinical areas. Rather, they are adjacent to the clinical spaces, so that no matter where you are in the building, from a common point of confluence, you can reach them in a streamlined manner. So consistency of movement is also important to reach the efficiency of design quality when you plan a hospital building. Accuracy of error-free distributions. This is the next quality of design efficiency which we would like to share. So this is the a picture of the building that we saw earlier. This is the Madhav Netralaya Eye Hospital, one of the largest ones that will come up in Maharashtra, 250 beds of eye care. And this is how the building looks. It had these kind of beautiful panoramic windows, because you don't need much daylight inside eye hospital, so the window apertures were designed in a very frugal manner. But it's a curved building which has a lot of drywall cladding, as you can see. And here what was interesting to notice is that when we were in the studio, we realized that actually the aperture of the window is very subjective to the doctors and nurses' suggestions, which you will not ever get at the beginning of a healthcare design project. These suggestions kind of come at different milestones, different stages of the design journey, which indicates the point that medical planning is an evolving mandate. It's not even after the hospital is built, you will get a new user group, you will get a new change in ownership, or you will get a new standard which you need to follow. So we realized that design has to be really fluid. It has to be flexible right from the get-go. But it's not just the user group, it's also about cost. For instance, if I do a wet cladding versus a dry cladding, if I do a stone clad versus a stone laminate clad, I would be working with different vendors. I would be working with different sizes of materials, which is very difficult to kind of draft all the time. So how do we kind of automate some of those requirements is what we were trying to explore. And it's not just in plan, it's also as an architect for us to think about how it will look in 3 dimensions. So depending on what are the spaces behind the windows, sometimes you might change, or sometimes you realize like this is not working here, we need to shift it down the line. So these kind of approaches help you to be highly flexible. Which comes to this point that the freedom of design is actually a sort of a creative liberation of the architect, which becomes the measure of their flexibility in design. So here you can see how you can try to coordinate movements in 2 dimensions and try to project and map them 3-dimensionally onto the building.
And the 4th point is the 4th point is the transparency of the IPD floor functionality. So what we wanted to do is take, again, the same building, the same floor plan, take one of the IPD areas over here, let's say the ward, and apart from the engineering aspects and the civil aspects, also look at what are the medical aspects. So in the ward, one of the most important factors is, can your nurse, wherever you locate your nurse station, do they have a access to all visual access to all the beds? So there is something called as the nurse's vision of cone view. So this green circle that you see is the nurse which is moving around the ward, and you can see what exactly do they see within the ward itself. So based on wherever you place the nurse station, you can have a visual check of whether you are capturing all the beds in your ward or not. So I'll just let the video play. One important aspect of this is not an animation that is done in post, ki design ho gaya, abhi, just put up on the website will be, oh, this is what we did. These tools are actually built inside your CAD, so the engineers and architects will notice that this is my AutoCAD screen, and I'm able to use these tools right at the time that I'm designing the ward itself, not in the time of after a post review or after taking prints and sitting with a doctor that I need to sit and look at these things. So this is what the image looks like when all your nurse stations are occupied, and you see that every bed has been covered with an overlap of some of the beds. And this is another of the wards. So this is a daycare bed. So there are no walls in between this daycare bed, in this daycare ward area. So you can again see how the nurse moves and what the cone of vision is. So in this particular ward typology design, 2 nurse station wards, one placed at the corner and one placed at the center, sort of covers all of the area within the ward itself to ensure that you have a proper nurse station visuality.
Right, so that was the transparency of the design process, not post-design, which is like, I want you to think about that for a minute, what that means. So coming back to the four components of quality, exploration, consistency, accuracy, and transparency of quality. When we were making this presentation, we realized that there cannot be just four, right? There ought to be many more. So we wanted to ask the question, like, is there a bonus quality apart from these four? Design efficiency for what? So does anybody have any suggestions, like all of this is for what? Like, why are we trying to create technology for design efficiency? Anyone would like to just blurt an answer? Sorry? Time saving. Anybody else? Sorry? Human-centric outcomes, very nice. Anything else? Future ready, patient centricity, time saving. Anyone? We have a lot of time. We are much ahead of time.
Constructability.
Constructability. Great, great. Anything else? Nobody's thinking of anything else?
More work in less time.
More work in less time. Yes. Sorry? Optimization. Great, great. Doing the right thing the first time. Yes, that's like the motto of the design studio. I think all of us might have been relating to this. But what my brother and I were thinking is that apart from all of this really important terminologies, is something much more worth of quality. So what we thought is that the bonus quality of efficiency is that design efficiency as a sign of good design. And what I mean by good design is something that propagates the culture of healthcare design. So what we would like to do is invoke the hidden quality of efficiency by saying that all of these technological inventions and applications also have a hidden quality to propagate the meaning or the value of a good design healthcare culture. And for that, I just wanted to put some pictures together. So recently, I started taking a lot of pictures of site visits, and that's Dr. Desai, kind of on site, showing us like the images of construction, what's happening on site, and kind of propagating sort of the horizon of healthcare architecture. Whether it be with clients or with the media, we kind of like to take this craft of technology very seriously. And even if it's in the design studio, that's Nandini ma'am, that's Sameer sir, going over drawings, or this like really funny image when we were trying to make a model of the design that we did. And I remember here, like this is like I think taken at 2 a.m. where Dr. Desai was very curious to know how a model is made, because he had never seen something being constructed with such intricate detail. So design culture is very important, and if you are an architect or a designer, you are also looking forward to the agility of design. So a sketch is a really agile tool. It's a very archaic tool. It's like goes back to cave paintings, right? But digital tools are also giving us that agility. So for instance, here we were trying to negotiate what should be the height of the window, Like for a daycare ward, the height of the window will be something else. For a public cafeteria, maybe you need a much bigger ward. Maybe in an OT, you don't need it at all. So how do you bring that agility from a sketch environment into a model environment? That is what we were like trying to explore. But also another quality after propagation and agility is the quality of crafting with care. I think that's something kind of gets missed out in this whole number crunching, saving time, optimizing, like all these big O words, like an industry which is so heavy with timelines and pressure building upon you to deliver. It's like we forget the care of crafting space. I don't know why these videos are not playing. Okay, I'm just gonna try it again. Yeah, so at the studio then we try to 3D print the model once it was digitally done, but we didn't like it, so we went back to kind of remodel the bricks, like we were still not satisfied, so try to kind of make it ourselves, and that's like Ishan holding the output like very proudly, kind of thing. But that's what we mean by like crafting with care is also an important part of technology, and I think technology gives you that edge, like to bring that humaneness into the process. And we would like to conclude by saying that we feel these 4, 5, 6, 7 qualities is what we would like to kind of share with you. And we really feel that quality is like the heartbeat of the design process, and that it's very difficult to achieve. It's easy to achieve in quantity, but not in quality. And we would really like to see and hear your thoughts about what you think about quality in design techniques. And with that, I would like to thank you all. And yeah.